Okay, here we're going to take the entropy balance into control volumes, where I have the mass flow that coming in and out of a control volume. Okay, so it's a similar equation. Well, let me just kind of go through it here. So on the left side, we have the rate of entropy change in the volume that you've got. So as things change in the volume, you've got this rate of entropy change within it. Okay, just like in the first law, we have a rate of entropy transfer that accompanies heat transfer. So that's Q over T, okay? And then we basically have entropy in minus entropy out. So these are the rates of entropy transfer accompanying the mass flow, right? So you've got some amount coming in, some amount going out, aiding in that rate of change, okay? And then at the very end, we've got sigma dot. That would be the rate of the entropy production, okay? So it's a similar equation to what we had before, okay? With a closed system, it's just I've got mass flow, in, out, that sort of thing. Okay. Now, the equation that we actually use in this course that we're dealing with here is our steady state entropy balance. That's when the rate of entropy change equals 0, right? Once you get up to steady state, there's no property changes. So within the control volume at any given time, the entropy is constant within that control volume. So you get 0 equals, the Q over T dot, and then entropy in minus entropy out plus the entropy production. And again, this entropy production has to be positive, just like it was with the first law. So this is really the equation, that we kind of use most often once we get to steady state. And again, it's just very, very similar to the closed system equation. Just you've got mass flows, and it's rearranged just a little bit. Okay. Now, when I've got one inlet, one exit, this looks very much like what I had before. Okay, where I've got my mass flow times a change in entropy, right? Where basically you just have one thing coming in, one thing going out, like in a single stage turbine, or the heat transfer, to a reservoir or something like that, where you've just got one inlet, one outlet, right? So you've got mass flow times that change in entropy equals, again, that entropy due to the heat transfer, and then any entropy production. So again, very common case for us is when I have one inlet, one outlet, I can rearrange that, and that equation looks really similar to that closed system. Again, just dealing with lots of dots because I have rates of change with the mass flow and things of that nature.